Hi everyone and welcome to the channel. We're back with part 2 of the recreation of my Windows XP PC as it was way back, back at the end of the year 2002. Now in part 1 we spent a lot of time doing a lot of painting, a lot of cleaning, etc. trying to get this case to look as close as we could to the case of that PC all the way back then. There'll be a link down in the description if you haven't seen part 1 if you want to check that out. But here in part 2, it's time for us to get some hardware inside this case. But what hardware is it going to be? Well, let's take a look at the couple of pictures of the case and we'll see what we can figure out. Now as before, due to the terrible quality of these pictures, there's not a huge amount that we can pick out. Most of this is going to have to be done either from memory or by me looking at old emails of receipts, that kind of thing, just to figure out what hardware exactly was in there. But there are a couple of things. First up, if we have a look at that fan that's in the middle of the picture here, we can see that it's kind of rotated round at a bit of a sort of funny angle. And the reason for that is the cooler on the CPU is a Zalman CNPS 3100. And if we take a look at a picture of that, this is what Zalman called one of their flower type coolers. So you've got all these thin pieces of copper in this case, they're clamped together at the bottom, and then the fins kind of splay out, I guess a bit like the petals on a flower, hence the name. However, that makes it very difficult to attach a fan directly onto the cooler, and so the fan had to be held on this bracket that I just described. So they're a little bit different, a little bit unique compared to the sort of traditional, socket 7, socket 462 type cooler. So that's definitely something that we're going to have to try and incorporate into the build. Now switching to this second picture, you can see that we've got three things in the 5¼ inch drive bays. The bottom two bays, they're taken up by optical drives, but the lower of those two drives, that's a slot load DVD drive. Now slot load drives, I really like them, but for whatever reason they never really took off in desktop PCs. So again, that's a little bit different, bit unique, so we need to try and recreate that. And the thing above the two optical drives, that's one of those combined temperature sensors and fan controller thingamabobs. So I'd like to put one of those in this build, but I just haven't found one that I think sort of fits, in terms of looks with the rest of the build. So if anybody out there has got any suggestions of a sort of temperature sensor / fan controller thing that mounts in a 5¼ inch bay, drop us a comment down below, and if we can find one, that's perhaps something we can come back and add to this build at a later date. Okay, so since we can't see much more from the pictures, let's go back to the desk and we'll have a closer look at the hardware that we're going to be using. Right, let's start by thinking about the CPU we're going to use in this build. Now I can't be 100% sure what CPU's in the system in those pictures, and the reason for that is overclocking. You see, back then I was in my early 20s, I had an okay paying job, but I didn't really have many financial commitments, so you couple that with a love of overclocking and, well, let's just say I got through a lot more CPUs than I perhaps should have done. Now that kind of went on until the Athlon 64s, but yeah, certainly from that kind of K6 period up until the Athlon 64s, I got through quite a lot of hardware. So the CPU we're going to use is this. It's an Athlon XP 3200 Plus. Now I'm fairly sure that this wouldn't have been the CPU that was in those pictures because this didn't come out until a few months after those pictures were taken. However, whatever Athlon XP CPU was in that system, it would have been overclocked to as close to this kind of speed as it, as I could have got it. Now the model number for this CPU is AXDA3200DK4VE. So that means we've got an Athlon XP, it's in this kind of brown coloured organic PGA package, and it's got the Barton CPU core. So even though it's got 3200 in its model number, that was a PR rating. Its real clock speed is just 2.2 GHz, and that's on an 11 times multiplier on a 400 MHz bus, But even that was actually a 200 megahertz bus, but it was a DDR bus, so you got two transfers of data for every clock cycle. But what's this PR rating all about? Well, when the Athlon XP line came about, AMD gave them all this PR rating, and the reason it did it was that the Athlon XPs, they were quite efficient processors for their time, in that they did quite a lot of work for every clock cycle, whereas the equivalent Intel CPUs, they didn't do as much work per clock cycle, but they ran at faster clock speeds. Now the problem with this was that Joe Public would go in to buy a computer, to your big box computer shop, and he'd go, okay, this one here, for example, this runs at 2.2 gigahertz, but that Intel one runs at, let's say 3 gigahertz. So that one must be faster, and they'd buy the Intel CPU. Now AMD thought they might be missing out on sales because of this, so instead of calling these Athlon XPs by their real clock speed, they gave them this PR rating. Now AMD said that this stands for performance rating, and it's designed to let you sort of compare one Athlon XP to another. Well, I don't think a lot of people really bought that, because you could already compare them by clock speed pretty well to begin with. And it just kind of happened that a, say, PR rating of 2.8 gigahertz or 2800, you got an Athlon XP that ran at the same speed as the equivalent 2.8 gigahertz Pentium CPU, or near enough. But according to AMD, it definitely did not stand for Pentium rating, and was not what what you were supposed to do with it. You weren't meant to use it to compare to the Intel CPUs, but everybody did. I also said this CPU die on here, the CPU core, said it was a Barton core. Now, if you don't know the core sort of history of the AMD Athlon, let me just sort of very quickly explain. When the Athlons first came out, they came in this sort of slot form factor, like these Pentium 2s did. So I haven't got a slot Athlon to hand, but just imagine this is one of the original slot Athlons. Now, the processor's on a card inside, and it's got this edge connector in the bottom, and it would slot into a slot on your motherboard the same way your expansion cards still do. Now, the size of the CPU die in here, well, the size of the little transistors that make up the actual CPU itself in the die, they were at 250 nanometers, and if you look at a picture of one, you'll see that CPU die in the middle, and you'll see this, we've got a black chip either side of that die. Now they're the level 2 cache chips. And this is what was called off-die cache, because it's literally separate to the CPU die. Now as AMD started running that CPU core, the processor, faster and faster, the level 2 cache chips couldn't keep up. And so, relatively speaking, they were running slower and slower compared to the CPU core, to the die, and that was limiting performance. The original Athlons, they were also only running on a 100 MHz DDR bus too. So what AMD did was they took that design and they kind of revised it, they refined it if you like. They made it faster, they made it run at a higher bus speed, they made the little transistors in the core smaller, and they repackaged it back into the more sort of traditional pin grid array format, PGA format, where all your pins, they're laid out in a nice grid on the underside of the CPU package. Now they called that revision the Thunderbird core, and that's where we've got the Thunderbird core Athlons. I mean, this is the equivalent Duron, but again, I've not got one to hand, just pretend it's the Athlon. Now the other main thing you'll notice about this is there's no separate level 2 cache chips. It's all now integrated into the actual CPU die itself, and this is called on-die cache. And what that means is that the level 2 cache is now running at the same speed of the core. So all these improvements meant that AMD could start to clock this a bit faster again and get more performance out of it. But it's important to stress that even though there was that revision, it's still an AMD Athlon. It was just an evolution of the design, not a sort of new processor, not a revolution. Now, once they'd kind of got to the limit of that, they did the same thing again. They kind of refined it a bit more, made the features, the transistors that little bit smaller, added a few more features, and cranked up the bus speed, and then you got this. This is the Palomino core. And then they did that again. Oh,
just to say, this was when they started calling them Athlon XPs. They did that again, they got the Thoroughbred core, and then finally one more time, and you got the Barton core that we're using here. Also, by the time they'd got to this, the bus speed was up to that 200 megahertz that we mentioned earlier, you know, the effective 400 megahertz on DDR. So each of these steps, it was an evolution of that original Athlon. Now, once they'd got to this point, this was about as far as they could push this architecture. So then you kind of had a revolution, if you like, a new processor, and we ended up with the Athlon 64s and, you know, all the kind of refinements that came after that. So anyway, yeah, this XP 3200 Plus, I've probably rambled on about these enough, so I think this should make a good processor for our build. Right, let's move on to the motherboard.
Okay, so here's our motherboard. This is the ASUS A7N8X-E Deluxe. Chipset on this is the Enforce 2 Ultra chipset from Nvidia. And yeah, that Nvidia. So for anybody who wasn't sort of into computers back then, the Nvidia from now, the graphics card guys, well, back then they also made motherboard chipsets too. Quite successfully, did it for a number of years in a few different sort of generations of CPU models. So specifically, we've got an Enforce 2 Ultra 400 North Bridge under that heatsink there, and this is the MC-P-T South Bridge. There was a few revisions of that South Bridge that integrated different features into it. But just before we get into those details, can we just take a moment to sort of appreciate the positioning of this North Bridge chip? Now, it's probably a very good technical reason for doing what they did, perhaps something to do with timing of signals in and out of it. But when you take just kind of one main chip on a board, or, you know, it doesn't have to be a motherboard, could be a graphics card, whatever, and rotate it through 45 degrees, it just kind of doubles the awesomeness of that board. I don't know why, it's just one of those things, but it just does for me. Maybe it's just because it's kind of going, look at me, there's something a bit different, a bit special about this. But yeah, it really works. I mean, you couldn't take all the chips and rotate them 45 degrees. That'd just start to look a bit weird. But when you just do it with one, yeah. I don't know why. As I say, it's probably just me, but there's something about the way these things look, and it's brilliant. But what have we got here? Well, it's your socket 462 socket on here, so support for the Athlon and Duron series of processors. You'll also notice that whilst we've got the old sort of plastic tabs on the socket for CPU coolers, holes were also starting to appear in motherboards around this time. So these, as coolers were getting bigger because processors were putting more heat out, we were finally starting to realise that clamping things to these little tiny plastic tabs probably wasn't the best idea. So just like we still have these days, holes in the motherboard for attaching the sort of bigger coolers to. 3 memory sockets, even though it supports dual channel memory, so if you've got a couple of 2 or 3 DIMMs in there, you've got to make sure you got them in the right sockets so you get the full sort of dual channel mode. Don't think it made that much difference if I remember, but we'll make sure we set ours up like that. The AGP slot, notice that's a little bit longer than normal. This is an AGP Pro slot. It never really took off, never got a lot of traction. It's the same as a bog standard AGP slot, supports AGP 8X on here, which was as fast as AGP ever got. But these extra connections, I think these ones down here at the front, they were supplying more power to graphics cards as they were starting to get more and more power hungry. But of course the problem with this is you've got to feed the power into the motherboard and then along the motherboard just to get it to this slot, and sort of very quickly as power connectors started appearing on graphics cards instead, I guess we just settled on the idea that it was much more efficient to go straight from the CPU into the graphics card without trying to shove more and more through the motherboards. We've got 5 PCI slots and then this little black slot on the end. I think it's something to do again with those communication and network riser things, but useless little things, never really got used very widely at all. Got our main power connector here, floppy disk drive, and then 2-channel IDE setup. You'll notice we've also got a couple of serial ATA ports on the side here, not handled natively by the by the M-Force 2 chipset. Got this Silicon Image SATA link chip there, which was responsible for sorting those out. We've also got a second network port on here, which you'll see when we have a look at the rear ports in a second. But one of these chips on here, can't remember which one it is now off the top of my head, but there's a second chip on here for handling the second Ethernet port, which gave you Gigabit Ethernet. This was one of those functions that later got taken on board into the South Bridge there. So looking at these rear panel connectors, we've got PS2 keyboard and mouse. There's our 2 Ethernet sockets. I'll have to double check which is Gigabit Ethernet and which is just 100 megabits. 2 lots of USB ports, both those for all these are USB 2. Parallel port, serial port, then we've got 5 3.5mm audio jacks and an SPDIF out as well. The audio in these, that's handled by the Southbridge again, and it's I believe 6-channel audio on this, so not too bad for an onboard audio solution. Certainly better than some of these sort of AC97 type stuff that was still kicking around at the time. Internally on the board, there's quite a few connectors on here. Not many jumpers, thankfully. Almost everything's handled through the BIOS by the obvious 1 or 2 things, like clearing your CMOS, for example. But there let's see, we've got the second serial port up here if you want to use it. Gamepad port. There is a couple of Firewire ports down here, which again all handled, I think, by the N-Force chipset. We've got 3 fan headers on here. Front panel audio, connections for those IR blaster, the infrared type ports, and a couple of internal audio connectors. So yeah, not quite the highest end board that ASUS did for this, but still pretty well represented in terms of features that you typically found on PCs at the time. Now, a bit like with the CPU, I don't quite think this was the board that I had in the case at the time of taking the picture. I don't think it was quite out yet. I think it came out just a little bit after that picture was taken, but I did definitely upgrade to this exact model of board, and I did have that, this board, or not this board, but you know what I mean. I had this board in that case. So a bit like with the CPU, ultimately this is the one that we're going to go for. So how are we going to keep that CPU cool? Well, remembering back to the start of the video, I said we had the Zalman Flower CNPS 3100 on there. Now, I've never been able to find that cooler, and I have looked for a long time, but I have managed to find one of the next models in the lineup. This is the Zalman CNPS 7000B. It's an aluminium and copper mix. As you can see, there was also a version that was all copper fins on it. And we've now got this sort of round design, and obviously the benefit of this is it means the fan can be integrated into the cooler itself. There's no need for that sort of awkward bracket suspending the fan above it. It mounts using some little brackets that go through the holes in the motherboard, so we're not on the little clips, so that's great. Little brackets just screw into these holes here and here on this sort of central mounting piece here. Usual 3-pin connection for plugging into the motherboard fan headers, but it did come with one of these little fan controllers, so you could run the cable via this and manually dial in a lower fan speed if you wanted these things to run a bit quieter. But they weren't noisy coolers to begin with, even at the sort of full 12 volts that they'd normally get. So a bit like the original Zalman cooler that I had, the consensus with these was pretty much that they were sort of middle of the road coolers in terms of both noise and cooling performance. Yes, you could get coolers that were better than this, but they were louder, and you could certainly get coolers that were quieter than this, but they perhaps didn't cool as well. To be honest, I think it was probably getting to the time where, after spending a number of years constantly overclocking with loud, screaming loud fans,
my ears and my head was probably getting ready for a bit of a rest, which is, I guess, why I started using these sort of coolers around this time. Okay, for the RAM, nothing special here. I've got two 1GB sticks of this G.Skill DDR400 RAM. So we're going to have 2GB in total, but because we've got two separate sticks, it means we can run in dual channel mode. So that'll give us the fastest RAM speed, fastest sort of total amount of memory access speed, if you like, that we can. Now, it's not particularly fancy RAM by any means. It's only cache latency 3, but this will be fine. This will be fine for that system. I don't think I'd have had 2GB installed at the time of that picture, but I don't believe in kind of limiting the amount of RAM too much on machines that I want to be using all the time. As I've said before, I want to use those machines. I don't want to sit there and wait for them to do things. So it could certainly put more RAM in if we wanted. Windows XP supported up to 4 gigs of RAM, but that came with certain caveats that I don't really want to deal with, to be honest. So 2 gigs of RAM, certainly for early in Windows XP's life, this will be absolutely fine for that system. Okay, let's look at the graphics card next. Now, it's going to be a GeForce 4 card, and back when that picture was taken, I had a GeForce 4 Ti 4200. Now, the other main models in that lineup were the 4400 and the 4600. Much later on, a 4800 came out, and there was also the sort of more value-oriented MX line, but the three I've mentioned, they were the kind of main range. Now, the 4200 was much cheaper than the 4600, but it was a really good overclocker. You could typically overclock it to very near to, if not the same performance as the 4600, so that's what a lot of people, including myself, went for. Now, my 4200, I had one of those Zalman flower type coolers installed on that as well. Zalman brought some out that was specifically meant for mounting onto your graphics card. Now, when I've been putting parts together for this build, I thought there's no chance I'm ever going to run across something like that again. I mean, I figured out they must be sort of pretty rare by now. But then this thing came up for sale. This is a GeForce 4 Ti 4600, and as you can see, it's already got one of these almond flower GPU coolers. Can I say GPU? Did we call them that back then? Anyway, Zalman Flower graphics card chip coolers installed. Now, I'm not going to take this cooler off because, credit to the previous owner, they've done a cracking job of putting this on. And in terms of condition, this is absolutely immaculate. There's barely a speck of dust on this thing. They've done a really nice job with it. And the other thing that stands out, other than the cooler on here, is just look at that PCB. It's freaking purple. I mean, that's fantastic. I don't ever recall seeing many purple PCBs. I mean, this thing, it's probably not going to go very well with the lighting that we've got for inside the case, but yeah, purple PCB, I like this a lot. Of course, it does beg the question, who made this thing? Looking on here, there's not a lot of clues to help us. I've done some Google searching, just trying to find images of this card, and I think this is an Asus model, possibly a V8460. However, when you look at pictures of those Asus models, just there, you've got an Asus logo, but here we've got an Nvidia logo on this one. And if we turn it over, we can see that we've got this N1996 silk screened onto the card here. This was typically put on the, who made them? I can't think now, but the Inspire range of computers. That was typically printed on parts that went in these. So maybe this was made by Asus, but it was made for an OEM or something like that. And then, as if that weren't sort of, convoluted enough, it also says creative on this sticker up here. So assuming that's original sticker, is that creative? But then looking at pictures of creative GeForce 4 cards, can't find any with purple PCB. So I don't know. This is something that we're going to have to investigate a bit more when it's installed, and we can sort of get the software to have a bit of a poke around in it and see what we've got. However, all that aside, this is a bog standard TI 4600. We should have 128 megs of DDR memory running at 650 megahertz. That's under all those little blue heat sinks. It is the sort of 4 behind here and 4 more that we saw on the back of the card. Those blue heat sinks, they came as part of the GPU cooler kit. And the core clock on this, that should be running at 300 megahertz. Now, the model of this cooler, this is a Zalman VF700. As I said, again, it's a flower type cooler with all these kind of clamped together individual fins that then splayed out in this sort of circular pattern. You see, we've got an all copper one this time, and sort of 2 sizes of fin. We've got these much smaller ones here so that we don't start running into components down on the motherboard. Only slight difference with these is the fan doesn't plug into the graphics card fan slot. That needs to go into your motherboard or be powered separately. And just like with the CPU flower cooler, you could run that via one of those little manual fan controllers if you were looking for, say, a bit less noise out of these things. Right, we've sorted out his eyes. What about his ears? Let's see what sound card's going in here. Now, back in that picture, I had a Sound Blaster Audigy. I can't remember the exact model. It would have probably been something sort of fairly middle of the range. But yeah, the Audigy, these were the successors to the very successful Sound Blaster Live series of cards. And while they were a little bit better than the Live, you know, you had better frequencies and sampling rates and all that lot, lower noise, etc. They didn't wow me, these things, like the Sound Blaster Lives did when I first heard one of them. I guess we were getting to the point with sound where you could almost recreate things near perfectly. So these sort of incremental steps that were left would get smaller and smaller to the point where they kind of lose that wow factor. I mean, don't get me wrong, it might just be my bad ears and I just couldn't hear the differences that were there. But yeah, it was kind of underwhelming, shall we say, compared to the previous cards. In fact, it actually meant that the Audigy was the last sound card or dedicated sound card that I had in my in my main computer, and that's true still to this day. All the sort of built-in onboard sound has always been good enough. Although I will say that the drivers and the sort of applications that come with some of the onboard sound things have they've left me about this close to buying a dedicated sound card just so I didn't have to use the damn things. However, when I was looking for the card to put in this build, I also found this. This, as you might be able to see on the silk screening for this chip here, is a Sound Blaster Audigy 2. So again, the next step on from the Audigy ones, and I presume just like the Audigy ones, while the specs are all very much better, I imagine that in sound-wise it'll be pretty pretty similar. So why have I got this thing for putting in the build? Well, this is an Audigy 2 Platinum EX 6.1. So yeah, great, we've got 6-channel or 6.1 channel sound and later revisions of environmental audio extensions and all that good stuff. But you see, we've got the EX in the name. We've got a 4-pin floppy drive, that's the Berg type power connector here. I've also got this odd looking connector here for the back of the card. Now that connects to this thing. So this is an external I/O module, and as I sort of hinted at there, the EX in the model name for that sound card means external I/O module. You remember the Sound Blaster Lives and the Audigys, you could get the internal one, the Live Drive, or whatever they then called it when it was the Audigy line, the one that went in the 5¼ drive bay. This is the sort of external equivalent of that. And when I saw the sort of silver front on this, and then we've got the silver case, I thought, yeah, this is going to look fantastic sat next to it. So I decided to pick this one up. So all this essentially does is give you a load more inputs and outputs for connecting into your sound card. You can see we've got Firewire, optical in and out, the big chunky 1/4 inch connectors for line in, mic in, headphones out, that kind of thing. Mic volume, master volume, that could be quite useful. One of those little CMSS, that button there, it's for activating some sort of filtering, noise cancellation or something. We'll check that out when we've got it installed. And we've got a little receiver, because this thing also comes with a remote, which I'll show you in a second. But yeah, looks wise, even though I might not use any of these, I will. We'll find something to use them with. But yeah, this should look really nice, I reckon, sat next to the computer. Quick look on the back, a couple more Firewire ports. There's the add link. This is the where that funky looking cable goes in. In fact, here is that cable. It's almost sort of two cables in one. You've got your connection to here, and the other one of those that goes into this Firewire type port thing here. I've got to be honest, I'm not very familiar with Firewire. It's not a sort of connection that I've hardly ever used. So if I've got anything wrong about it and you're screaming at the screen, that's something I'm perhaps going to have to look into a bit more in the future. Yeah, we've got some MIDI in and out, we've got some RCA line in, some more digital in and outs here and here on sort of various different connectors. So yeah, if you're into your sound and your music, these things are pretty full featured, I would imagine, for you know, for having to play around with that. So here's our remote that comes with it. So you know, typical sort of plasticky feeling remote with the little rubber keys. It does this sort of typical stuff like volume up and down, mute, etc. And then you've got sort of track controls, I would imagine, for when you're listening to your media. Not sure what else we can do with this. I think once we've got the software for that installed, we'll have to have a bit of a play around with that to see what else we can do, what sort of programs we can control and what functionality we get. So just briefly back to the card. So that floppy disk drive style power connector, I would imagine that's for shoving sufficient power down the cable to drive that external module. It comes with a cable that adapts that to your standard 4-pin Molex in case you haven't got any spare floppy disk power connectors in your PC. And then looking at the ports on the back, we've got the cable connector along with a Firewire type looking connector here for that dual cable that connects to the external module. And then we've got three 3.5mm jacks. They're just labelled 1, 2 and 3, so I would imagine these will be software configurable for you know, line-ins and line-outs, depending on exactly how you got your speakers set up. So yeah, there we go, Audigy 2. That's what we're going to use. We'll see how it sounds when it's in there. Okay, let's have a think about some storage. I'm going to use this. It's a SanDisk SSD Plus. It's a bog standard Serial ATA 240GB drive. Like I alluded to with the RAM earlier, I'm not interested for an everyday use type PC waiting for the hard drive to spin away and do things. So we'll go for an SSD and speed that part of the system up as much as we can. Now in terms of connecting this to the motherboard, you may remember when we had a look at that, it has two Serial ATA ports on board. Now they were sort of quite new for the time, and the manual is not very clear about what you can do with those. It certainly mentions using them for RAID. It doesn't actually mention a whole lot about just using one port as a boot drive. I would imagine that we can do that. And we'll have to get the drivers in during the Windows XP installation to let it do so. But if we can connect it via, natively via Serial ATA, that's definitely what we're going to do. Failing that, we'll have to use IDE, and then we'll put one of those IDE to Serial ATA converters into the back. I mean, I've done that before, and that works well, but if we can stick to native Serial ATA all the way, I think that'd be a nicer solution. Okay, DVD drive. I've managed to find a slot load. I haven't tested it, so I hope this thing works. But yeah, we've got a slot load drive. And I've sprayed the front of this silver so it'll match the case as best we can. There was a time, certainly with the with the standard tray load type drives, where manufacturers would supply alternative fronts, usually beige, black or silver, so that you could put the right front on to match the colour of your case. But obviously I haven't got anything like that for this, so the sprayed front it'll have to be. Just looking at the model of this, it's a DVD 106S. I think it's Panasonic who made this. Pioneer, sorry, not Panasonic, it's a Pioneer drive. Can't remember the exact model number that I had, but yeah, it's a slot load, that's the main thing. Standard IDE interface, so yeah, this is, I think this is going to look nice. Sat in the front of the case, should be a good one. And likewise for the CDRW, this again, it's been sprayed silver on the front to match. This is a Sony drive. It's a 52 speed read, 52 write and 24 rewrite. We were pretty much at that time where, CD drives got, I guess, as fast as they were ever really going to get, barring those one or two exceptional drives, that I think wasn't there I can't remember who made it. There was one that ran at 72 speed or something daft like that. Again, bog standard IDE interface on the back, so we can get both optical drives on one cable in a master and slave setup. Now, one mod I would like to do to this drive is to stealth the front of it. It was a little sort of case mod that quite a few people did back then. What you do is you take off the drawer front and you take off the rest of the plastic surround on the front of the drive, and you get a spare drive bay blank and you attach that to the tray instead of the existing front. And then you set the drive in your case such that the drive bay blank is level with all the other blanks in the front of your case, and it effectively hides the drive. But there's enough sort of slack in the mechanism that if you tap the bottom corner of the drive bay blank, if I could not drop it, it's usually enough to activate the switch underneath, and then the tray slides out with the blank on the front of it. Now, I can't do that unfortunately because the case that we're using, it's got 4 drive bays in it. We've got 2 optical drives. So I need 2 drive blanks and I've only got 2. So that's 2 for the remaining holes. Obviously I'd need a third in order to stealth mod that drive. So if we can get a fan controller, if anyone can suggest one that we can use that will suit the looks of this case and mounts in a 5 1/4 inch bay, we'll then have a spare case drive bay blank, and at the same time we'll be able to do a little stealth mod to the drive. So yeah, if we can find a fan controller, I'll do a little follow-up video at some point in the future where we will install that fan controller and we'll do a stealth mod to this too. Now I'm going to put a 3.5 inch floppy disk drive in there, again sprayed to match, but there's 2 reasons for this going in. Number 1, there was one in the original PC, so let's have one in so that we're sort of recreating it as close as possible. And number 2, a bit like on the 5 1/4 inch bays, there's 2 3.5 inch bays. I've only got 1 cover, so we need this in to cover the hole in the case. Right, got some bling cables for connecting up our optical drives and the floppy drive. Yeah, rounded IDE cables. We were actually starting to, give a little bit of attention to airflow through the cases, and especially as people were overclocking and CPUs were getting hotter. The broad, the wide IDE cables and floppy disk drive cables, they're just brilliant at blocking airflow through a case. So you could get these things where they're rounded and the cables are kind of sleeved up there, so you can route them a little bit easier and you get better airflow too. These ones just happen to be UV reactive, but no UV lights in there, so it's not going to make a difference. But yeah, this is what we had, so we'll put some rounded cables in too. Okay, finally, we're on to the power supply. Normally for these systems, I like to put a new power supply in them. I find that at least gives you the best sort of confidence that, nothing's going to blow up, all your components are going to be fine, etc, etc. But the problem is, we've got that window in the side of the case, and virtually all new power supplies are black. Now, we need something that kind of looks period correct, so I've got this new old stock A-Open unit, and it's in that proper sort of period correct silvery grey metal colour. I think it's 350 watts, so should have plenty of power for our system. We've got the usual complement of connectors on here, motherboard connector, lots of 4-pin Molex connectors, and this P2 connector, I think that was just an Intel system thing. We won't be needing that one. Now we've got a nice big 120mm fan in here. That's temperature controlled by the power supply itself, so shouldn't be too noisy either. And that's going to look just right in the case. So there it is, all our hardware laid out on the desk and ready to go. It feels like I've skipped over parts of this pretty quickly, but no doubt when I come to edit this, I'll find this video's probably already longer than it perhaps ought to be. But there's certain bits of hardware here that I think deserve their own video. They deserve looking at in a bit more depth. So I'm definitely going to come back and revisit some of these in the future, and we'll have another look in a bit more detail. But anyway, that is enough for me rambling on for now. Let's get this hardware built into the case. Okay, we've got all our hardware installed in the case at last. Well, I say at last. I mean, it took a little bit longer than I thought it would, that build, but it was still a fun one. Couple of things to note. First thing, the two serial ATA ports down there at the bottom of the motherboard. I did say we'd probably connect the SSD up via, straight to the SATA port and try booting that way. However, the silk screening on the board identifies them as SATA RAID 1 and SATA RAID 2, so coupled with what the manual says about those being sort of just RAID, there for a RAID configuration, I think we'd be wasting his time trying to just boot off one of them. So for now, I've just gone back to the serial ATA to parallel ATA adapter, and this is plugged straight into the, straight to the IDE port as normal. However, maybe in the future, perhaps a bit of an upgrade, get another SSD connected straight to the SATA controller, RAID, stick them together in a RAID array. Might make a nice upgrade for this machine, maybe. I don't know, just something to think about in the future, perhaps. Oh, and just while we're on the subject of SSDs in Windows XP, before anyone drops a comment and says, oh, XP doesn't support the trim command properly, or you'll knack your SSD and all that kind of stuff, to be honest, I'm not really too bothered about that. I mean, it's not like this is my work PC and I need this to make a living off or something like that. Yes, it's an everyday use PC, but at the end of the day, it's there for fun. So if I get a few years down the line and find the SSD's knackered because XP didn't support trim or whatever command. So what? You know, it doesn't matter. We can always put a new one in there. Second thing, flipping heck, is there ever a lot of cables in here to try and manage? I kind of forgot, just, you know, builds of this here era, just kind of how many cables there were that you're constantly sort of trying to hide and keep out the way so as not to, you know, impinge your airflow too much. I mean, these rounded IDE cables, they are better, you know, than the flat ones in some respects, but this one here, I really wanted to kind of get it tucked underneath the SSD there, but it was just kind of pulling down on this little board too much, you know, the converter, and I don't really want to stress that connection and end up breaking it, so that might have to stay there, might have to do something different with it, but yeah, just Molex connectors everywhere. I mean, the two intake fans, they've got a Molex connector each. The lights, the sort of bubble lights at the front, they've got their own Molex connector. We've got the one here for the sound card. And then at the back, I've put this 120mm fan in. That's going straight on its 3-pin header to the motherboard. It has got this kind of nice little 3-speed selector switch on here, so that's quite a neat little solution. So I just took that up there out of the way. Then between the CPU fan and the graphics card fan, I've decided that since the graphics card fan is the smaller of the two, it potentially could be the kind of noisiest of the pair. So I've decided to run that one via the little sort of variable speed controller, and then eventually that makes its way back to the motherboard and it's into the power supply fan header on the board. So whatever the BIOS sees as the power supply fan header, it'll be the one for the graphics card. The other thing is, the cables that come out of this are about 40 to 50 centimetres long. So again, you've got all this sort of cable to bundle up just here. It's just a bit of a pain, to be honest, but yeah, not to worry. And then just sort of down here at the bottom, I had an empty slot. You know, I didn't have a suitable slot cover for that, and I don't know why, but empty slots on the back just bugged me for some reason. So I was just gonna put just a card in and not connect it up, and then I realised I didn't have the front audio ports connected and the front USB ports. Now there's just one solid connector on the back of this little PCB for those, and I couldn't find the cable. So I checked the earlier footage of when I took this case to bits, and there was no cable that came with the case. So I can only presume that you know, previous owner or owners have just lost that at some point. So it's a little tricky because both the 3.5mm audio and the USB ports are in one sort of solid connector, and I would imagine that at some point you know, there'd have been a cable that came with this that broke it out into the motherboard headers for USB and front panel audio. So I think because I haven't got the right cable, and I'm going to have to sort of take that out, do a bit of probing around, figure out what pin on the connector is what, just going to have to leave that for now. So I've taken the front USB ports and mounted them to the back on this extra bracket, so may as well have them doing something. And since there weren't enough cables in this thing already, I thought, sod it, we'll put a bracket with a gain port on there as well. So we've got this ribbon cable in the bottom for the old style, I can't remember, what was it, 15-pin gain port or whatever it was. So yeah, still a bit of work to do. Obviously we've got to get the case lighting in, but before we do that, I think it might be wise just to connect this thing up and switch it on. Let's check it posts. Let's check that it gets to the BIOS. Like I said, I'd hate to get all the lighting in and then find out this thing doesn't work and we've got a problem and have to take it all back out again. So I'll grab a keyboard, mouse, monitor, etc. We'll power it on, cross his fingers, and we'll see if it posts. Okay, here we go. Let's press the button. Brilliant, straight into the BIOS, just what we wanted. The date and time are almost correct. Flipping heck, that's not bad going at all. Okay, so we've got his SSD, that's there. We've got his two 5¼ optical drives, that's good. All our RAM is showing up. Let's just very quickly go to hardware monitor, make sure we've got all the fans are on, nothing's overheating, anything like that. Okay, everything looks okay in here. Motherboard, CPU temperatures there, nice and cool, which is good. Weirdly, chassis fan, which is this 120mm fan at the back, is showing nothing. our power fan, that's the graphics card fan with on the little adjustable, fan speed control. Let me just try turning that down. It's on maximum at the minute. Oh, that's interesting. That's dropped to nothing 2 now. I wonder if it gets to a point where it's lower than what the motherboards can pick up for some reason. Set that back to maximum. This is on low. Yeah, let's turn that to high, see if it picks that one up. It still might not be fast enough. Okay, well, it's not picking it up in the BIOS, but I don't know if you could hear it in the audio. It's a lot louder on high than it is on low. Here, I'll flick it back down. Just going to turn off the full screen logo. I don't know why, I just like seeing what the BIOS is saying rather than showing as a fancy picture. And this was quite an interesting feature. The Speech Post Reporter. I think if you got an error, this motherboard would actually try and tell you what that error was over the PC speaker rather than giving you a series of beeps. I would imagine if you weren't aware of that feature and your computer suddenly developed an error one day, that could be, you might jump out your skin the first time you hear that. Okay, so 200 megahertz CPU frequency, 11 times multiplier. It's picked all that up itself, and I presume we can adjust it. And that should give us our 2.2 gigahertz for this CPU, so that's good. Okay, let's exit and save changes.
It's just trying to do a network boot. I must have missed that in the BIOS. I need to turn that off. It won't be doing network boots. We just want to boot straight off the C drive. But yeah, that's great. Everything's checked out in the BIOS. No magic smokes come out or anything like that. So let's get the case lighting installed, and then that should be the hardware side of things done. Okay, going to finish the video off with a bit of a voiceover since I've just seen how long this has got, and I can only apologise for that. So we'll make this ending nice and quick. So, case lighting, no LEDs here. We're going old school with some period correct lights. We've got a couple of cold cathode tubes to put in the case. Now, if you're not familiar with them, they're a bit like a sort of fluorescent light in that you've got this tube, it's filled with gas. You put a high voltage across the ends of the tube and you get light out of it. So in this pack I've got 2 red tubes, so they're an exact match, or should be an exact match for what we're recreating. And you also get this little inverter, so effectively that'll plug into the power supply at one end, and our 2 tubes will plug into the other end, and then that'll take care of supplying them with the correct voltage and current that they need. So to mount them in the case, you get these little sort of sticky Velcro type pads. I do tend to find that if these aren't quite cut to size properly, they can sort of attract a lot of dust that's blowing through the case. So I might use these. If not, I'll use some of those little sort of command hook type things. We're going to put 1 tube on the bottom down at the front, so that'll sort of just tuck neatly behind the side panel and not be too visible, and corresponding tube up at on the top of the case, on the underside of the top, not on the top, that'd be weird. But then that gives us the kind of the best sort of most even spread of light I think that we're going to get. And then all that's left to do is to mount the little inverter in the case, finish tidying up the wiring. Put the side of the case back on. And it's time to switch on. And there we have it, looking good. And if you are still watching this close to the end of the video, thank you very much for sticking with it. I really appreciate that. It genuinely means a lot to me. In part 3, we'll have a closer look at the case lighting, but the main thing is we're going to get Windows XP installed, and we're going to get some of the early Windows XP software installed too. Hopefully get a good nostalgia kick out of that Windows XP software that we all remember using. And I promise I'll make part 3 shorter than this one. So I hope you've enjoyed this video. Thank you very much for watching it. If you have, drop us a thumbs up, comment down below, tell me not to make stupidly long videos, anything like that. But for now, I'm just going to say thank you very much for watching, and we'll see you in the next one. Bye bye.